So today's lesson is an introduction to graphing inequalities. And graphing inequalities is super similar to graphing equations. However, you have to take into consideration two special things. We have to think about what kind of line we're going to use. And we also, for the first time, are going to start shading in one side of our graphs. But besides that, the inequality is just like an equation, where you will look for point and slope, the y-intercept point and the slope, and go from there. However, like I said, we have special lines that we use. And so if you have simply a less than or greater than equation, notice what our lines are. We use a dotted line, dotted or dashed line. And we use this kind of line because we're saying that technically the points on the line are not included in our answer because it's not equal to. But the points can be up to that line without including that line. And it's kind of the same idea as when we would graph on a number line. We used an open circle. Open circle is going to be our dotted or dashed line now for these inequalities. Then, if it's less than or equal to, or greater than or equal to, we use a solid line. And that's going back to when we were graphing on number lines with inequalities, we would use a closed circle. Closed circles meant the point was included. The solid line means that the points on the line itself are included, while our dashed lines mean that we're not going to include the points that fall exactly on the line. And so we need to take that into account when we're going to start graphing inequalities. The second thing we need to consider is to determine what side of the graph to shade. And so with shading, what you need to do is you have to test a point to figure out if it satisfies your inequality or not. And this is very, very easy process. So the question is saying, is the point -2, 3, so this orange dot right there, is it a solution to our inequality? And so our inequality 4x minus y is less than 2 is already graphed. And if you notice a few things, it's a less than symbol, and notice we have a dashed or a dotted line, because technically those points on the line are not solutions. And so to determine what point to test for shading, you can choose any point on the entire grid. It doesn't have to be the point -2, 3. You could have used any single point you wanted. However, let's test the one that was provided, and let's see what happens. So if I plug it into my inequality, I get 4 times -2 minus 3 is less than 2. Let's solve. 4 times -2 is -8. Minus 3 is less than 2, which gives me -11 is less than 2. Yes, this is a true statement, and so it is a solution. And notice down at the bottom it says, if it is a solution, then you're going to shade the side of the line where that point fell. So my point was -2, 3, and it's on the left-hand side, and so that is the side that I'm going to shade. That entire side gets shaded in because everything in orange now is technically a solution. And that's why we have to color in a side of a graph, because all of those points work. Not just the points on our line like an equation, but everything off to the side works. However, if it would not be a solution, then you would have shaded the other side. And if you would like, you can test another point just to make sure you're shading the proper side. Now, in order to graph inequalities, we have a few things we want to do. Just like when we were graphing equations, we first have to put it in slope-intercept form. And so, if you forgot what that is, remember we want to solve for y. And so that's what I'm going to start with. by minusing 2x on both sides, I get a negative 3y is less than negative 2x plus 9. I'm going to divide by negative 3 to all of my terms. And remember, when you divide by a negative inequality, you have to flip your symbol. So I have y is greater than 2/3 x minus 3. Now, I have to determine if I'm going to graph a solid or a dotted line. I notice that it's just greater than, and so technically we're not including the points in my line, so I need to use a dashed line. So my y-intercept's at negative 3. My slope is up 2 over 3, up 2 over 3. And then I can draw in my dotted line. And there we go. Now, step number 2, it says to choose a test point to determine which half to shade. And so, if I can, I always like to choose the test point 0, 0, just to make my life a little easier. And I also like to use the original equation to have less chance of errors. So 2 times 0 minus 3 times 0 is less than 9. 0 is less than 9. Yes, it is a solution. And so because it's a solution, I am going to shade that side of my graph. If it would not have been a solution, I would have shaded the other side. And remember, you can always choose any point you wish. And there we have it. Here's another problem. Graph the inequality y is less than 2x plus 5. Go ahead, try it on your own, see what you end up with, and then come back and check to see if it matches mine. So looking at my solution, I was able to graph the inequality right away since it's already in point-slope form, and I used a dashed or dotted line. And then for my test point, I chose the origin, which was clearly on the right-hand side of the graph, or the bottom side of the graph. And from there, the origin made it a true statement when I solved the inequality, and so that is the half that I shaded. Now, last but not least, we are going to write inequalities to represent given graphs. And now, thinking about this, it's actually not as hard as you may think or as intimidating as it seems at first. And so first, you always want to analyze when you're given a task, what do we know? And so looking at this graph, think about what we know. What kind of inequality symbol does it have to have if it's a solid line? Well, solid lines, remember, either less than and equal to or greater than and equal to. So right there, we know it's going to be one of those two symbols. We can easily look at a graph and find our slope. I see we go up 3 and over 2, so I know my slope is going to be 3/2. And right there is my y-intercept at 3. And so writing an inequality in slope-intercept form is really not too complicated. It's going to be y. It's going to be one of our inequality symbols, and then 3/2 x plus 3. And so what I like to do is I like to test a point. I'm going to put in the origin, and so 0 something 3/2 times 0 plus 3. And this is going to end up being 0 something 3. Well, I know 0 is less than or equal to 3, and so I have to use the less than or equal to inequality symbol. And so right there, I just wrote an inequality for my graph. And I tested a point to make sure that it worked.